Today I'd like to remind you about flowing fluids. So we're going to fill up this water jug and we're going to try to figure out flow rate and speed of water. You'll notice that the jug tells us that it is 7 liters. We're going to turn on the water and wait till it gets to its top speed, and then we're going to start timing it. Remember, when we find flow rate, we can have it in things like gallons per minute, in this case liters per minute. We could do liters per second, but the standard unit is cubic meters per second. We are now going to try to fill up the water jar again, but this time I'm going to cover up part of the opening of the hose. This time I should have the water come out at a higher speed, but not necessarily at the same flow rate. Let's give it a try. Okay, I would like to remind you of a few things about continuity of flow. So when you look at the water flowing through this hose and coming out the end, the flow rate has to be the same in both parts. However, when I cover up part of the opening and make it come out faster, this flow rate does not have to be the same as this flow rate. When I cover this up, this flow rate does have to be the same as the flow rate now. At any given moment, the flow rate in all parts has to be equal. Remember what's happening here. When I cover up this opening, I cause a pressure buildup in the back. It causes the water to shoot out at a higher speed. This will be a lower pressure. This will be a higher pressure. Flow rate equals flow rate. This flow rate does not have to equal that flow rate. The final thing I'd like to show you is water hitting broccoli. Look at the way the water just runs off of the broccoli. The broccoli leaf doesn't even get wet. The water doesn't stick to it in any way, shape, or form, and runs right off the end of the broccoli leaf. I don't know why we don't make our raincoats out of broccoli.